bit more detail here in a minute. I'm Dave Rooney, I'm moderating this, and we have two speakers, Doug Duncan and Alex Rudolph. You can see the pictures up in the
Click and black.
You can match now. Doug will be our first speaker, and Alex will do cleanup, or he's the power giver, yes. Doug was our 2011 Emmons Award from the ASP for college level teaching, and he has also served as the AAS education coordinator. He's currently director of Physical Planetarium, member of the Astrophysical and Planetary Sciences Department at University of Colorado Boulder. So very well known. These are both stellar astrophysical researchers, which always makes me so happy. Right. And Doug got his degree from UC Santa Cruz. He and I postdoc at Mount Wilson Observatory. It just seems like just a couple months ago. And he's also worked at Space Telescope, University of Chicago, and Adler Planetarium. We all know him and love him as Dr. Clicker. Alex Rudolph is professor of physics at California State Polytechnic University at Pomona. Got his PhD in physics from the University of Chicago. He has an NSF career grant to his credit, and he is an incoming ASP board member. So he's the guy you talked to today about, oh, the meeting went well, or gee, we needed more coffee, or could we have chips? So I'm not that person. Alex has been very active, as has Doug, in AstroPad research, and Alex is known for interactive teaching strategies, our concept inventories, and looking at relationships between student demographics and predictions of learning. We're going to have two short interactive presentations. So if you don't have a clicker, put your hand up so we can get one in your hands. If your clicker doesn't work, you're not getting the send and receive signals, put your hand up and we'll get one with hopefully fresher batteries in your hands as well.
And when you get a clicker, what's the frequency code?
Don't mess with that.
Just leave it on.
Turn it on.
The default.
Okay, if you have, so we're going to have two quick presentations. If you have questions, I'm going to ask you to jot them down and hold them until after the two presentations, and then we'll have a rapid fire open discussion time. Okay?
Yep.
So,
All set?
start with Doug.
Great. Okay, so as you may have noticed as a teacher, our students are changing their behavior on a faster time scale than most of us change. Question I'd like your feedback on is here in front of you. So please make a choice, A, B, C, D, or E.
Those of us who don't teach can answer this question. So with clickers in general,
Yes.
do you pick up an abstention?
Do I pick up what?
An abstention. If I don't press any, will that be read as, you know I have a clicker but I'm not answering?
So right now, of course, we're doing one use of clickers, which is just statistically to learn what you all are thinking. And so you would just be ignored in that case. If this was a class, the system records every student response under a unique code, and then it would matter. So we can talk about that in the discussion if you don't mind. Okay, so 19 of you have answered. I think a couple of you are abstaining.
Now, if you press it twice or
20.
that you press it once.
Yes, your last selection is what counts.
Okay.
Okay, 20 of you have answered. I'm going to stop. And I bet you're curious what your classmates have said. So let's go ahead and show what the results are. Wow, interesting. This is the kind of thing that generates a lot of discussion in class where it's equally divided. Almost perfect. Okay, so later on in the discussion, now that you all know this, I hope people will give their reasons for yes and no, and we'll give our advice for whatever that's worth. Okay, when you teach, What percentage of your students do you think are using electronic devices while you talk?
So do you mean laptops and computers too?
Any electronic device.
What if they're using the laptop to take notes during class?
Do they,
Count that too.
Count that too.
That's contaminated by your policy if you're permitting this.
I'm asking you, not me. I just want to know what people in the room say. Okay, so I will stop counting. And this is what you say. Let's see. There we go. Okay, during the discussion, I will tell you that the people answering D are right, and the A, B, and C are optimists.
I assume a couple of them will have dead batteries.
Right. I'm fortunate, in Colorado, we have a $10 million of research in physics education research and some in astrophysics. So we can afford to do a lot of things like interviewing students anonymously. And these are typical, not selected quotes from the students when we ask them what's going on during class. Our researchers sit in the classroom disguised as students, and so that gives us a reality check to what the students might report. So when I tell you what percentage of students are using devices, mostly phones to text, it's because our researchers, AKA spies, have reported those percentages.
How big are the classes you've been looking at?
Our physics classroom where astronomy is taught holds 212 students.
That's a big class.
And every semester we average 8 classes and the room is nearly full. It's about 75 to 80% is average attendance.
Okay, because some of us are coming from schools where there's 30 per class. It's a lot easier to...
It is, but it still happens. I've seen it. So that's what when we compare faculty opinion to what the researchers see scattered through the room anonymously. It's just really hard, even if you walk around the room. Okay, this is a fun one. Some of you have read our paper published on this topic in the ER, which as far as I know, is the only published data on this number. So, what do you say? Only 10 people have answered so far. Oh, that's better. Okay, 3 seconds left. 2, 1, if you want to register your opinion. So we'll stop. Wow. They do read the literature. And even better, somebody reads my papers. So this is now 2 years worth of data in 8 large astronomy classes at the University of Colorado. This is the first of the 2 years. Oops, was that?
That's okay, I'm just moving this a little bit out of the way. So
Yeah, the critical number. And this is the 2012 data.
Is that self-reported? Where's it coming from? Self-reported?
So the way we gathered that data, that's one of the nice things about clickers when they're widely used is you get the statistical data. So we told the students this would be anonymous. We brought in a separate clicker system from the professors. We asked them to respond and then we left. So, and we also observed them, so we think they told the truth by and large. Oops, I'm sorry. We were talking about this as you came in, a couple of us. What do you think? If instead of buying a $30 clicker, somebody comes to you and says, oh, offer all your students apps. You know, they're only $3.99. Good idea or not? What do you think? Oh, I see, right. You just move over a little bit. I'll see when everyone has answered. Perfect. 3 seconds. 2, 1, We'll stop, and this is what you say. Good. I don't know about you, I am being bombarded. I think it's just because the companies are startups who are making apps for phones now and telling you, don't bother to buy clickers. I vote B. I'm sorry, we have the data. And when you talk to the students, it's not like they're trying to screw up their grades. Your students honestly believe they can multitask. And if you give them a phone with Facebook available and a clicker system, they'll spend much of the time on Facebook and come back into astronomy class only when they have to. That's what we've observed.
What about an app that locks them out of all those other apps?
I've never seen one.
But wouldn't that be cool?
It would be cool, I don't know if it's legal.
And you don't think, you don't think you could just shut it off and turn it back on? I mean, think about it, you know.
I've actually talked to students about designing a jammer for the room.
Yeah, right, so, but now think about the cost of a jammer. I mean, you know,
I know.
you're thinking, I mean, these things are pretty cheap.
I know.
So the last slide that I brought is kind of a metacognition for us all. When I went to Adler Planetarium in 1992 to plan their spending $50 million, I negotiated being sent all over the US, and Germany and France and Canada actually, to study the best science museums, the very best, exploratoriums, Lawrence Halls. How do they plan the educational programs that work so well? And what I found was they differ from 90% of the scientists that I work with. Most of my colleagues go, look, they've invented an iPad. Think of all the wonderful things we could do in education. Look, Hubble has sent back these great pictures. Let's use them in teaching. All I can do is report to you that the top places turned it around, 180 degrees. Who are we trying to reach? College freshmen? College seniors? Outreach. What are the characteristics of the people coming in? What do they know? What are the preconceptions? What motivates them? Then we say, when they finish with our class, how do we want them to be different than the day they walked in? We want them to know more astronomy? Great. We want them to like astronomy? Great and different. We want them to think astronomy should be funded in the future? Also great, but different. And when you have a very, very clear goal, then you say what technology will lead me to the desired result. And it could be a clicker, it could be a colored card, it could be a pencil, it could be the internet. Okay? So that has saved my museum years and years and hundreds of thousands of dollars to have very clear goals.
Okay. So we'll have, I'm sure you have a lot of thoughts and questions for Doug about technology, and so we will go through what I have to say, and then we'll come back and have questions about all of these things. So I'm going to talk to you about demographics of your class and a little bit about, so who's in your class and then what helps them learn. So this is a question I'm asking you about what helps students learn. And ascribe, just for those who don't know, is any sort of intrinsic characteristic of a person. It's not something that you gain, but you are, this is something about you that you have relatively little control over. So, let's see what people think about this. About 5 more seconds. Okay, and just to see how you guys came out. Okay,
Wow.
so quite a mix.
Not as many have read.
It's okay, it's all right, it's all right. So, good, all right, so let's go on and try in the second one. Now these are achieved characteristics. These are, on the contrary, things that a student achieves through their own efforts or through their being who they are as they go through life. And which of these would be the most important? And the Astro 101, I assume everybody knows, is the GE class that people take for astronomy credit.
It's really good to have the data. We got 20, that's
Okay.
our magic number.
Yep, okay. And, okay, most of you think the number of physical classes you have, and some say GPA. Okay, good. activities overall is the largest factor in student learning in Astro 101.
How is this different from the last question?
It's basically asking, there's something on there that wasn't on there.
Oh, okay.
It's a different mix of questions, a different mix of items. It was not, neither ascribed nor achieved, it's something else. External to students.
Okay, student number 20, time's up.
Okay, so even if you haven't read the paper, you're kind of good at guessing. Okay. That's fine. I wouldn't be standing here probably if that weren't true. So I'm going to tell you a little bit about the data. So I have data on all of those things I just showed you. I'm going to show you the data in a moment. But first I just want to describe briefly what the study was that we did. Some of you may know this, but in case you don't. All right. So we did a national study of learning in Astro 101. This was led by Ed Prater of the Center for Astronomy Education. There's two references at the bottom. I'm happy to give one in the American Journal of Physics, one in the AER. And this is just, so we chose the light and spectroscopy concept inventory as our tool. We did pre and post testing in a total of 70 different sections of classes in 31 different institutions. We had almost 4,000 students participate, and the map just shows that it was national in scope. And we had sections, and I should mention that the institutions were of all types. We had 2-year colleges, 4-year comprehensive universities, research universities, every type of university you can think of was included. And we also had class sizes varying all the way from as small as less than 10 up to 180. And I should add that after this paper was published, Ed Prater went on to then teach using interactive techniques that he had developed and tested in this study in a class of 700 in a large auditorium. And it confirmed the same result applies even as large as a class as that. So this is how we collected the data. And we also did at the same time a series of demographic questions to the students, such as describe things like gender, ethnicity, English as a native language, parental education, the ones you saw, and the achieved characteristics you saw, plus others that we didn't end up using, that didn't end up showing up in our models, but we did a total of 15 questions that we asked. And so this survey gave us a snapshot of students across the country in Astro 101. And one result, which I don't have a slide for, but which I will tell you, is we were able to compare just the distribution of types of people in these different categories, men and women, different ethnicities, different types of background and income and so forth, and compare to, there's an organization that collects data for all colleges and universities across the country. It's a big survey, I forget the name of it right now, but they do all college freshmen across the country, so we can compare our data set, which we thought was sampling Astro 101 classes, against U.S. college population in general, and there's no statistically significant difference between them. So in other words, Astro 101 students are college students. They're just the same. They're the same type of students. And the statistics show, in fact, that about 10% of all college students take Astro 101. So we're actually influencing a significant percentage of all college students in this one type of class, which is why we put so much effort into this study. Okay, so here's the result. Oh, I should mention one last thing, is we did do an additional survey of the faculty, asking them what they had spent. So the faculty in this study had been through one or more of the CAE workshops on interactive learning, but not all of them did the same thing with that information. Some of them did no change in their class, some of them completely transformed their class, some did something in between. So we asked them a series of questions, just self-reported, about not how to interact with their classes, but what did you do in your class? How frequently did you ask a thin pair sharing question? How frequently did you do a lecture tutorial? And other activities of that sort. And then we used a rubric we created to create a score, which we called the Interactivity Assessment Score. And it really was just a percentage. What percentage of class time did you spend doing something interactive? And that number varied from 0 to about 50%. The top people did about half their time doing interactive things, and some people did none. And this was biased, obviously, towards people who tended to be interactive. Of course, the majority of instructors are probably closer to 0 because they haven't been to a workshop or don't do these things. But we had a range that covered a pretty nice range of interactivity. And that became another piece of data that we could feed into our models. So what we did was we did multivariate linear regression, where we fed in a variety of these characteristics plus interactivity, as inputs into a model trying to predict the gain that each student got on the LSDI. So it was just one, that was the dependent variable. And we actually did it doing a series of models, adding variables in pieces, because that way we could see how the effect of each chunk of new characteristics were changing the predictability, how much prediction power the model had. I'm showing you the final model, which has the full data. And when you do these types of models, you get, I was going to put up a slide, but basically, any of you would know, think of it, a constant plus A1 plus B plus B1 x1 plus C1 x2, A0 plus A1 x1 plus A2 x2, and so on. And so there are these coefficients come out with a standard error. And those are all different from each other because one can be measuring gender, which is 0 or 1, depending on whether you're male or female, others can be your GPA. But then you can recalibrate those in what's called standardized coefficients, where you just express them in standard error, that is, the value over the sigma. And those are comparable, right? You can compare those. So that's what we do, is we then look at those standardized coefficients and see which ones are big, which ones, first of all, are statistically significant, and then how they compare to each other. So what I'm showing you, the final slide I have, is basically a chart showing you the standardized coefficients of these various things. And if there's no asterisk, it was not statistically significantly correlated at all. So ethnicity, whether they spoke English or as a native language, their parents' education had no effect on their learning, in fact, in this study. All the ones with 2 asterisks had a p-value of less than 0.01, which means that it's less than 1% chance that that's just a random result masquerading as a real result. And then you can compare the sizes of the bar. So actually, gender wasn't the most important. The only actually ascribed characteristic that seemed to matter, and this is a well-known sort of bias that's in a lot of science classes where men do so much better than women. Of the achieved characteristics, the level of math was the highest, followed by the amount of science they had, followed by GPA and class grade. They all matter, which is not too surprising. These are all the things that help you learn better because you're just more mature or so forth. But finally, interactivity was the most important of all. And we thought that was really important because it meant that something like the level of math would be something you would intrinsically feel is something that should help students learn, and yet something that you can't control that typically. You can't give them more math right on the spot. You can't have them have more classes. You can't have them have a better GPA, but you can control what you do in your class. And that's something we have the ability to change, and it's as important as anything, including something that we think is quite important in math. The last point I want to make, and then we'll go to the general discussion, is that we did one further test, which is we actually asked the question, how does interactivity help within groups? So for example, there's a method using what's called cross-term, where we look at gender and interactivity and say, is there any difference between men and women and how much interactivity helps them? Is there any difference between ethnicities? Is there any difference between whether English is your native language and so forth? All throughout, and my other interesting relation was GPA. You sometimes hear people say, interactivity is fine, but it's really only for the bad students. The good students are wasting their time, it doesn't help them. It's only and they're getting held back, whereas the weaker students are benefiting. Well, we were able to look at that and say, was interactivity different for people with a high GPA or a low GPA? And the bottom line is, it made no difference. All students benefited equally. There was no statistically significant difference in any of these characteristics and how much interactivity affected their learning. So anytime someone tells you it's not, it will work for all the students because of their ethnicity, because of their class level, because of their GPA, you can say that's not true. So that's a very powerful statement to be able to make. So I think that's it. And now I'd like to see if we have both answers.
Before we even do that, there's unpublished work at Colorado that adds to your last point.
Okay.
Now we're teaching in a much more interactive way in upper division. And so the kind of concentration of our research right now is quantum mechanics, which students are taking maybe junior year. And so when the junior year majors were asked, should the class be taught with think, pair, share and clickers, their response at the start of the class was, oh no, that's for intro classes, it's for babies. But because it was an experiment, the instructors did it anyway. And at the end of the semester, they surveyed the students, and I think the figure was like 85% said, we're glad you did this. Do it again next time.
Right.
So I thought that was kind of interesting. The other common misconception is interactivity is for babies and freshmen.
So we'd like to throw it open for discussion. Yeah.
Does Astronomy 101 require a high level of math?
It actually typically doesn't, so we were curious about it, but on the other hand, you might think it does require, I mean, the way I teach it, a lot of people teach it, you do require a lot of physical reasoning. And so it's not too surprising that someone who's had more math may be just able to do the kind of physical reasoning, and sometimes there's, for example, there's a little bit of proportional reasoning that's required. So you might say things like, if you double the distance between two massive objects, how does the gravity change? If you put an object, things of that sort, where it might still help. So it just seems like it does still help to have more mathematics, even though you're not necessarily, and I can only speak for my class, some people may use some math in their Astro 101. I think Don McCarthy, who spoke earlier this week, is actually making a case that we shouldn't totally shy away from using math in those classes, that that's a very good thing to do. So some people may.
I was just thinking it was completely independent. I mean, students who take higher level math in high school, for example, may tend to do better independently or whatever math.
Well, and yeah, so you could argue, but one is college GPA and math level might or may not be related, but
such a person might be willing to work harder too, and stick with a problem.
possibly. Yeah, there's also, one thing you should realize that even in the best models, we're only predicting about a third of the variability in the data, which is not unreasonable in this kind of research where you have human beings. There's often lots of hidden variables. There's also the fact that somebody may have been sick the day that they took the post-test. I mean, there's also the fact that you don't know about, and we didn't measure everything. So we can only say about what we do have measured. Mike?
I was just going to say that I think at least as important as ability to do proportional reasoning is the ability to read a graph in Astronomy 101.
Also.
And I would guess that people who have higher levels of math have more experience.
There's more comfortable, right.
More comfortable with different
Sure.
scales.
I mean, astronomy is a mathematical science, and no matter how much we try to make it conceptual, which some of us do, yes, you've got to look at graphs, you have to use numbers, there are things like that in there. Sure.
If I can add a pontifical
Yeah.
point to what you just said, I think this is a perfect example of why it's so important to do this research and publish it. I can't tell you how many faculty meetings I've sat through at multiple different universities where everyone tells you what they think is happening on the basis of no data.
Right.
So being an experimentalist, I'm not even troubled by the fact that I know this is the answer, even if I don't have the theory yet to explain it, because I can use this.
I think you were next.
Sure.
Yes.
Okay, so in the quantum mechanics class, how big is the class? And are they doing things per share in there too, clickers?
Yeah, the class is like 40,
Yeah.
and they're upper division. And actually, so that's the immediate answer. I can tell you, every year I do a data analysis and introduction to programming class, and that is 12 to 15 students.
You still doing
And the
this?
first time I taught it, 6 years ago, I said to myself, oh, we don't need any of this stuff. We sit around on a big conference table, and my methodology was to choose one student and have them explain something on the whiteboard, and the others could ask a question. And I gave the first exam, and I predicted the average would be 80, and I still remember it was 56%. And I thought, oh my God, if they didn't know, why didn't they ask? And so I came in all ready to read them the riot act. And as I handed back the exams, I could instantly tell from their faces they were expecting an 80 also. So the reason that they didn't interact more was not that they were intimidated in any way. It was that when they saw Allison answer a question at the board, they said to themselves, yeah, that's what I would have written. But when they had an empty paper during an exam, it wasn't agreeing with Allison. You know, it's the difference between being the driver and the passenger in a car. You don't pay the same level of attention to detail. And so ever since, I have not used clickers, but I have used think, pair, share. I don't use any technology. I have the 12 students pull out a piece of paper, start to write an answer or write a whole answer, and just swap it with the person next to them. So they have to do the pair share. And the class average is now 75% instead of 56.
And I would just add that I also don't have a model up here, but we did look, I remember I said there were classes in the study that were as little as less than 10 all the way to 180. We saw no relationship with class size. So even in the smallest classes, it would be helpful to have interactivity help, regardless of class size. And I should also say, regardless of type of institution. So if you're at an R1 and somebody says, well, our students, I mean, of course, Eric Exert, the famous example of this, my students are Harvard students, they weren't going to need these things, and then he discovered that they did abysmally in the FCI. So we were just confirming that R1s are no different than community colleges, no different than comprehensive universities. It's uniform across the board. So the argument that my students, my class is too small, not at my school, just point to this paper, these papers and say, not true. Yeah, George.
Getting back to the questions Doug asked, am I correct that a lot of people do allow cell phones in class? And I think a bunch of people answer yes, and I
Well,
cannot
there's a
imagine.
difference, George, there's a difference between allowing them and not expressly forbidding them. That is, some people will sort of implicitly, I'm sort of speaking for Doug, but I'm saying this now, some people will implicitly not, they'll assume, of course, cell phones are not allowed, and they only say something if if they catch them. But if you ask students, if you don't say cell phones are not allowed, they assume they're allowed.
Well, what I want to know is there anybody in here who doesn't mind that students have cell phones?
Well, that, I don't know.
I realize that we.
Well, I'm not asking you,
Okay.
is there anybody here who doesn't mind?
If you're using clickers and some of them are using them as a response device, then you can't prohibit them because they have to use them as a response device. So occasionally they can look up something useful in class, it's kind of fun, but.
George asked.
Looking at their girlfriends' whereabouts.
George asked.
Somebody grabs it and they go, I'm regarding what you're talking about. And you go, I just posted that experiment on Facebook.
I mean, I will say this, I've seen students take out cell phones, I've seen people do this at this meeting, they take out their smartphone and they want to take a picture of the slide that's on the screen. Now, I tell them I'm going to post my slides after class, so they don't need to do that. So if I see them, I say, no, that's not necessary, you can get this slide later. But I see lots of people at this meeting, and I understand, I want to grab a piece of information, I take a picture. So they're used to using it for so many things in so much of their life that it's really not trivial to say, you can't use it. You have to be really firm that you will not allow it.
And to make that very good question even more complex answer, because you might think the answer would be yes or no, but it is more complicated. For instance, almost 50% of faculty that we surveyed don't say one way or another. Okay? It turns out that when you interview the students, almost to a student they say, oh, the faculty member gave us permission. Because if they say nothing, it's taken as tacit permission. And I was looking to find a slide that we don't have with us now, but basically we have 3 highly rewarded teachers, and so ignore the label because I'm faking it, okay? Very well respected teacher, a little bit formal, says in the first week, it's improper to use your phone during my class, but does not revisit that. And the level of use of phones is about 75%, and the class grades are down about here. Another professor is kind of in between, and about once a week mentions, okay, it's time to turn on your clickers and turn off your phones, and let's all pay attention and have a really good class. And they scored statistically significantly higher, but below the also good professor who, if a student is seen using a phone, walks over to the student and says, leave, and we'll see you next class. So it's very, there are gradations to it's okay and it's not okay and what is the penalty. And I think it's also true it better depend on your personality. I have kind of a hard time throwing somebody out of class. I'm kind of afraid they're going to think he's an ogre and then they won't participate anymore. The person who actually is the toughest in our department and throws people out is the youngest faculty member, but because he has a good rapport with the class always sides with him and against, the troublemaker.
Well, you guys are waiting, actually.
Well, now I was going to ask the part where it's like, what is your cell phone policy? What's your electronic?
I'm the one in the middle.
Okay.
Okay. I'm pretty happy with it. I'm debating mentally whether I should become a little more strict and throw Steve out. Every class, I start with 30 to 60 seconds of metacognition. Okay, class, it's time for learning. I explicitly talk with them, especially in the first week, but I repeat it. This is a valuable time. You are paying $20,000 to this university. You have me 3 hours a week, okay? You expect my complete attention, I expect yours. I will turn my phone off. I want you to turn yours off now, Okay, and so we have this ritual. I actually pull out my phone, I turn it off, I pull out my clicker, I turn it on. And I smile at everybody and watch while they do that. The use of phones in my class is still 25 to 30%, but I think they only do it maybe once a class instead of 7 times a class. It probably would be better if one day I actually threw somebody out, because the other person in our department, he doesn't throw many people out. It only takes about 1 or 2.
Have a shield.
And, okay, we might as well tell them the hardcore part. Okay, so then we do all the interviews. And what do the students say about this? A majority of the students say, thank you for making a good class environment. Okay, so they're not siding with the student who got chucked, they're actually siding with you, and especially with laptops. Oh my God, do they complain about if there's somebody in front of them watching a movie? Or Skyping, that happened once. Not in my class, not in the astronomy class. But there is a small but not 0% of students, I'd guess 8 or 10%, who told us in private, you can't tell me to put my phone off. My mother gave me my phone in 4th grade, and she said, never turn it off. And I haven't. It's been on since 4th grade. Now, interestingly enough, these are the freshmen in 2012. So these are the 18-year-olds now. There's a generation gap that we observed in our interviews between 18 and 21 or 22. So the current 22-year-olds remember a time before phones, and the current 18-year-olds don't. Yeah.
Well, I think my question, comment follows up nicely what you just said, and that is that, given that phones are becoming more ubiquitous, and not just that everyone has them, but they use them for everything, from taking a photo of a slide to looking something up that's relevant to the class, shouldn't we be moving towards appropriate use of the phone, not no phones, but phones for use as a device in class that helps with class?
So, sure. So this is personal opinion now, and Alex, I hope will have a different one, maybe Dave or somebody will have a different one. Absolutely not. Okay? One of the meta lessons, one of the reasons people come to university is they come out not only with different knowledge, but different behavior. You're going to go to a job interview. If nothing in your university experience has prepared you for a job interview, you walk in and say, hey, dude, or you dress the way my students usually do coming to class.
Or you text during the interview?
Yeah, I think the university has failed students, if we construe our mission, and I personally do, to be a little bit broader than just teaching the reason for the seasons. I have read studies that say the freshmen increasingly have difficulty conversing, engaging in conversation with adults, because most of their conversations are texting. And rather than, adapting to that and saying, well, they don't have conversation skills, I have exactly the opposite. It's okay, then they better learn in my class how to converse effectively with their fellow students and with me. And one pretty big piece of data in my favor is I live in the town of Ball Aerospace and down the road from Lockheed. And they hire a lot of Colorado graduates. And I guess I'm conspicuous because they often complain to me. And their complaints are all pretty similar. Our graduates are good at programming. We're glad we hired them, but damn, their communication skills are horrible. And we have design teams and we have teams that build things at Lockheed, and they can't effectively communicate in the team, and so they're a less valuable employee. So I think for most of the jobs that I know my students go into, the ability to write and communicate effectively is part of what they should learn in college. And so I would tell them, nope, you gotta learn this.
Well, and I guess the only comment I'd make is, how do you enforce the exclusive use of the phone for the things you want them to do? Mike was talking about having something that blocks everything else. I mean, immediately, I defy you to have an 18 to 22-year-old, and a lot of people older than that, frankly, have a phone or an iPad in their hands and not use it for more than just what they think they're going to use it for. And then the other thing is they think, there's a lot of research that people may or may not be aware about multitasking. Essentially, multitasking is a myth. No one multitasks. Some people single task very quickly, which is not actually very effective, but they're able to kind of keep them all going in some way that makes it look like they're doing a lot of things at once. The reality is that we all are effective as single taskers, and you need to focus on one thing at a time to do it. And so anything that this data shows, anything that takes you away from that task of being in the classroom, and especially in an interactive class where you're trying to get them to engage and really focus on what's happening and talking to their neighbor, it's just a distraction. And so I would just be inclined to say the same thing. No, I don't want to try to go down that road. Let's make the phone useful. I think that goes, the slide that Doug showed I really like about the technology question, because that happens all the time at my university as well. Here's a statement of technology. Let's use it to change the way we teach. That's the wrong way to think about technology. I love technology as much as anybody, but the way to think about technology is, what are the things we're trying to do in our classroom? Can this technology help? And will it maybe hurt in unintentional ways? And then figure out how to use it appropriately. And then you come up with really good ways to use computers and even cell phones. There are things you can do with cell phones maybe outside of class that could be spectacular. Have apps that do all sorts of cool stuff.
And do talk to employers every once in a while, because it's really interesting and useful. You know, we keep measuring the cognitive gains and we say, are our students better? But what I'm hearing from the Ball Aerospaces of the world is, yeah, can they talk about science and work on a team on a technical project? And that doesn't fall under cognitive gains, but if they're doing Think Pair Share and working on tutorials, I strongly suspect they're acquiring skills that the employers are saying they want.
I think you had your hand up a while back, didn't you?
Well, I was going to say that I work at a community college, so talking to the age gap, I have a lot more non-traditional students, and so I am not going to forbid somebody to not be able to use their phone, at least put it on silent, because they're elderly caregivers, they're kids,
Sure.
so.
Or they may have
They need
children,
to have
like they may
access.
parents.
Just
That's tough.
to kind of continue that a little bit, though, we get a lot of complaints, never in a timely way that we can do something about them, but at the end of the semester, the students who are irritated by the person who's next to them, who's using the, usually the phone, off task, they look to the faculty to fix that problem, but they don't tell you it's a problem until too late. So there's a fair number of students who get irritated by others in the classroom. And, we have a university motto, a rule, no student shall interfere with another student's learning. So if somebody is, playing music or something, you throw them out because they're interfering with some other students in the classroom. And so the students, again, in our interviews, they're pretty savvy. If someone is politely, kind of hiddenly texting or checking a message, that doesn't seem to bother them. If they have a phone that clicks, irritates them. If somebody's on a laptop showing something off class, it really irritates them. And they're not telling you, at least in our university, but at the end, when they write their evaluation of the class, a lot of them say, why did you fix this problem? So I do think it's perceived to be our responsibility. I think it is to be kind of aware of this, have some discussions with the students, and then manage it as best you can. Yeah.
To speak to your specific question, I do ask, or the rule is no cell phones, and if you are using one, assuming you have an emergency, no one will excuse you to take care of the emergency. And then if anyone needs a waiver to this policy, please come see me. And a couple of people do, and that's fine. And then I get to start to get to know them a little better. So that's
good idea. Many of our faculty have sections in the classroom. Almost everybody in my large astronomy department, laptop users must either be in the front row or the back row. The ones that say the front row, the students have to agree to only use it on the class. And since you're right over them, it's pretty easy to see, and they do that. And the ones who put them in the back say, screw it up if you want, you won't bother anybody.
So adding to this previous comment about students with children or other obligations, I have also heard, at least on my campus and many campuses, there's some kind of an emergency alert thing, particularly if they're waking somebody shooting. So the students will say, well, I need it to get my alert. So one way around that is you say, okay, I have a cell phone. I'm putting my cell phone here on the front, and if anything goes on, I'll let you do that.
That's good, yeah.
Our alerts get pushed to the classroom as well. So I don't know how it looks on other campuses, but.
Are the students aware of this research that it's going to cost them a grade? that they can't communicate, is not going to get a job because they look like
Yeah.
well, and that they text during interviews.
I hope they're becoming aware. This was published in 2012.
But they don't meet the academic.
No, but I've had probably 20 instructors ask for the particular histogram, and they all say, I want to show this to my students.
But can the students read the graph?